Okay, some quick revision on the structure of proteins. We're looking at proteins a bit more detail later in the module. We'll talk about their role in food in terms of structure and related issues. But for now, just a reminder, all proteins are composed of 20 standard amino acids. Primary alpha amino acids, said to be so because they have an amino group, the NH2 group, and a carboxylic acid group, the COOH group, substituted on the same carbon atom, said to be the alpha carbon. Remember, all of the amino acids have three things in common. They have a substitute, they have the hydrogen, they have the COOH group, they have the NH2 group, then there's the other group, the so-called substituent group, which in this case is the CH3 and methyl group. There's around 20 that are important for life. Most of them can be synthesized from the body from other nutrients. However, the ones in red are said to be essential, that if we must obtain them from our diet. Those with a star can be synthesized in the body, assuming we have a full complement of the other amino acids, including the essential ones. Amino acids are three-dimensional molecules and can exist in two mirror images forms called enantiomers. In life on Earth, the L form predominates to a huge extent among amino acids and proteins. There are a few D amino acids, but they tend to be associated with nasty toxins, and a few other examples, but almost certainly the L0R form is the one that matters. The peptide bond, the bond that when you synthesize proteins from amino acids, this is what forms. It's a loss of hydrogen, like many synthesis reactions. Amino acids react to form small molecules called peptides and large molecules called proteins, and this process involves the formation of a peptide bond, as described there. Yeah, that's the reaction there. Loses water. The reverse reaction, the hydrolysis, converse reaction, peptides and proteins can be broken down and hydrolyzed back to their original amino acids. In life, both protein synthesis and hydrolysis are carried out by enzymes. So we eat proteins that get broken down perhaps to amino acids, which then may go off to form new proteins, or in some cases may be used for energy metabolism as well. There are 4 levels to protein structure, which I'm sure you remember. Primary, the linear configuration of amino acids. Secondary, local 3D arrangements such as helices and pleated sheaths. Tertiary, the overall structure of the protein. And quaternary, what is often found where there's more than one protein working together. So we'll look at polyphenol oxidase later on, which is said to be a tetramer, because there's 4 identical proteins working together. Okay, there we are. Nice short one. Thanks for listening.